Hi everybody. That was just a short, fun little video. I thought it was cute, so give a shout to Mr. Anderson because he loves his penguins. So, yeah. All right, it's taking a look today, or we are taking a look today, not it's, at simplify and evaluate expressions. Okay, so there's a lot of properties of exponents going on here, different things. Most likely this will be a two-part video again. It's just a lot to go through, so we'll take our time, make sure we hit everything. Okay. So properties of exponents, bases must be multiplied or divided to fill in the empty boxes. You don't want to leave, it's all about simplifying things down, like condensing it down to make it look real nice. So we have a few big ideas when it comes to properties of exponents. So let's take a look. Our first is when multiplying expressions with the same base, add the exponents. So here we have 2x to the fifth times 3x to the eighth. You'll notice we did 2 times 3, which is 6. X to the fifth, x to the third. You can add the exponents, so we can get x to the 13th. So here's a side example, just to give you another one. 4x to the second times 2x to the 7th. Okay, 4 times 2 is 8. And we're looking at x squared times x to the 7th, x to the 9th. You are adding them together. Okay, all is well. When dividing exponents with the same base, subtract the exponents. Here I have m to the 6th divided by 5m squared. Okay, so you'll notice I have a 1 on top, so it still stays 1 over 5. Oops, 1 over 5. But then what I do here is I take my top exponent 6 minus my bottom exponent 2. That gets me 4. Okay, so let me do 6x to the third over 2x. I can divide the numbers. 6 divided by 2 is 3. 3, and there's always a 1 there if you don't see anything written. 3 minus 1 is 2, so it's x squared. Okay, it's a side example. When raising a power to a power, multiply the exponents. X to the fourth raised to the third. What you actually have going on here is you have 3 of them. Okay, that's what it means when you raise something to a power. So I have x to the fourth times x to the fourth times x to the fourth. And it's the same properties up here. You add them, boom. To make our lives easier, all we do is multiply here. So I could do something like x to the 7th raised to the 5th power. Okay, I wouldn't want to draw it out 5 times. So if I multiply here, I get x to the 35th power. Boom. Okay. If a product or quotient is raised to a power, the exponent gets distributed to each element. This one's really big and it's really easy to overlook. 2x to the 6th y raised to the third. This third power goes to all 3 terms. So 2 to the third, x to the 6th raised to the third, y to the third. And you just clean it up from there. Same works for quotients as well, dividing. 9 over 5x squared. You square the top one, you square the bottom one. So let me give you a quick little example here as well. Okay, we'll go with squared. This squared goes to all 3 terms. So 3 squared. Then I've got times x. I can multiply these, x to the 6th. I can multiply these, y to the 6th. I just realized that 2 times 2 is 4, not 6. Alright, and then the last thing is 3 squared is 9, so I have 9, x to the 4th, y to the 6th. Good. So this is another side example for you. Finally, if you have a negative exponent, switch the base 2 from either the numerator to the denominator, vice versa, and make the exponent positive. Simplified answers should not have negative exponents. You might want to put a little box around this. Okay. You'll never give an answer that has a negative exponent. Right? You always want to make it positive. Well, to make it positive, you flip it. Okay. So 2x to negative 3, you'll notice that only the x has a negative 3x for the exponent. So I flip it, I get 2 over x to the third. But same works if it's down low. 5 over 2 times xy is negative 1. Because this is a negative exponent, I can send it back up top. So let me give you guys 2 examples. I'll make it real simple for you. 3x to the negative 4th keep the 3 where it's at, but you send the x to the 4th downstairs. Okay? And vice versa. I mean, if you look at the other way, if I have something like 3 halves y is negative second. See how negative the exponent for y? I want to make it positive. I just send it back upstairs. Please note, though, that everything else in the problem stays the same. Only the thing with the negative exponent gets flipped around. Okay? The majority of the properties above can be easily figured out by expanding the expression. So, for example, if you look at number 2, you were asked to simplify x to the 6th over x squared. If you expand it, hopefully you guys are cool with x to the 6th, meaning that there's 6 x's. X squared means there's 2 x's. You can just cross them off. Gone, 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 gone. Count again. You have 4 x's up top. This takes a while. That's why we try to avoid it, right? But in general, it's an easier way of doing it. Okay, some not properties of exponents. Common mistakes. What happens a lot of times. Exponents do not distribute to addition or subtraction. So if I have 3 plus 7 squared, that is not equal to 3 squared plus 7 squared. What we do first is order of operations. What's 3 plus 7? 10. Then we square it. 100. Okay? And this one's huge. Make sure to distribute to all elements. 2a raised to the 4th power, 2a to the 4th. That 4th power has to go to everything. 2 to the 4th, a to the 4th. 2 to the 4th being 16. Boom. So it's a really simple one to fall into. Please be careful. Alright. What happens when exponents turn negative? Well, let's take a look. 4 to the 3rd. 4 times 4 is 16. Times 4 is 64. 4 squared, 16. 4 to the 1st, 4. 4 to the 0, just 1. Okay, that's an important one too. Anything raised to 0 power is just 1. 4 to negative 1, if I flip it, I get 1 over 4 to the 1st. So it's 1/4. 4 to negative 2 is 1 over 4 squared, or 1 over 16. 4 to the negative 3rd is 1 over 4 to the 3rd, or 1 over 64. So negative exponents make it smaller and smaller, okay, as it goes down. Okay, like the larger the denominator for a fraction, the smaller it gets. Okay, I have circled here a few problems. So we're going to try and do maybe the top 3 here, and then I'll probably end this video and we'll work on our next one. So let's take a look here. 2x to the 3rd times 3x squared. Please use your notes. Look right behind you, okay, the chart that we have on the front page. 2 times 3 is 6. X to the 3rd times x squared, you add the exponents, x to the 5th. Okay? So same base, add exponents. Okay? Good. Part B. I've got a negative chilling out front. Let the negative chill out front. The 4 can get distributed to both terms. So I get 2 to the 4th times x to the, I'm going to multiply these because it's a power raised to a power. So 3 times 4 is 12. Alright, now I can introduce a negative at the end. 2 to the 4th is 16, x to the 12th. Okay. Just a quick little note about the calculator too. I can't do anything with the variables on a calculator. So just keep that in mind. You can't just throw it in the calculator, hit enter, and get a number, or get an answer. Yeah. So you have to be careful about that. Okay. Part C. Negative 4, x to negative 1, m to negative 2, that whole entire quantity raised to negative 2 power. This gets distributed to all 3 terms. So, negative 4 raised to negative 2 power, x to negative 1 raised to negative 2 power, m raised to negative 2 raised to negative 2 power. Because this is a negative exponent, I'm going to flip this one and make it negative 4 squared. Here I'm going to multiply. So what's negative 1 times negative 2 squared? it's just x squared. And then negative 2 times negative 2 is positive 4. Okay, one last thing here. Go across your tops. 1 times x squared times m to the 4th. X squared, m to the 4th. Negative 4, that whole quantity squared. Well, negative 4 times negative 4 is 16. There we go. Okay? I have no negative exponents, and there's not more than one variable. So, like, I mean, it's all just condensed down to x's and m's. So we're going to pause right here. Okay? I will come back to this then. We're going to finish up the rest of these. But this whole ticket is up on the front of the page. Okay? It's these properties of exponents. If you guys know these right here, I'm telling you that you will be in tremendous shape. Okay? Alright, so keep up the good work, and as always, good luck. We're all counting on you.